Welcome back to Module 2, Physics. In this video, we cover momentum, conservation of momentum, impulse, angular momentum, and collisions. Momentum is a measure of mass in motion, calculated as mass multiplied by velocity. Like velocity, momentum is a vector, meaning it has both a size and a direction. A heavier object, or a faster one, carries more momentum, and so is harder to stop. The principle of conservation of momentum states that, in a closed system with no external forces, the total momentum before an event equals the total momentum after. Whether two objects collide and bounce apart, stick together, or even explode apart, the total momentum is always preserved. Impulse is a force acting over a period of time equal to force multiplied by time, and it is also equal to the change in momentum it produces. A short, sharp force and a gentle, sustained force can deliver the same impulse, the same change in momentum, just over different durations. This is exactly why crumple zones and airbags work. They stretch the same impulse over more time, reducing the peak force. Angular momentum works the same way as linear momentum, but for rotation, and is conserved when no external torque acts on a system. A classic example is a spinning skater. Pulling their arms in reduces their moment of inertia, so their spin speed, omega, must increase to keep angular momentum constant. The same principle governs the behavior of spinning gyroscopes and rotors. Collisions come in two main types. In an elastic collision, objects bounce apart, and kinetic energy is conserved. In an inelastic collision, objects stick together, and some kinetic energy is lost as heat, sound, and deformation. But momentum is always conserved in both types, since no external forces act during the collision itself. Pause the video and try this problem yourself. Momentum equals mass times velocity. 1,500 kilograms times 20 meters per second gives a momentum of 30,000 kilogram-meters per second. Question 1. What is momentum? The answer is B, mass times velocity. Question 2. A 1,000 kilogram object moving at 10 meters per second collides and stops in 0.5 seconds. What average force acted on it? The answer is B, 20,000 newtons. Question 3. In a closed system with no external forces, total momentum. The answer is C. It is conserved and stays constant. Here is your quick reference. Momentum is mass times velocity, and total momentum is conserved before and after any event. Impulse is force times time, equal to the change in momentum. Angular momentum is moment of inertia times angular velocity, and in collisions, elastic ones conserve kinetic energy, while inelastic ones lose some. That covers momentum, conservation of momentum, impulse, angular momentum, and collisions. In the next video, we finish dynamics with gyroscopic principles and friction. See you there.